Magnetism and Compasses. The primary function of a direct reading compass is to show aircraft heading with reference to the Earth's local magnetic meridian. It is now mostly used in a standby role, as a heading reference is now obtained from gyromagnetic compasses or inertial navigation systems, or even GPS. It's still mandatory for a direct reading compass to be carried on board an aircraft. The magnetic properties of a permanent bar magnet. It will attract other pieces of iron and steel. The power of attraction is concentrated at each end. When suspended horizontally, it will always come to rest in a north-south direction. Types of magnetism. Hard iron. Metals which are difficult to magnetize, for example cobalt, but once magnetized remain so for a long period of time. Soft iron. Metals which are easily magnetized, for example silicon iron, and which lose their magnetism once the magnetizing force is removed. Terrestrial magnetism. The Earth is surrounded by a weak magnetic field which culminates in two magnetic poles situated near the geographic true north and south poles. Magnetic meridians may be constructed with reference to these magnetic poles. True and magnetic meridians cross each other, and the angle between the true meridian and the magnetic meridian is called magnetic variation. Variation. When the meridian lies to the left of the true meridian, variation is said to be west. When the meridian lies to the right of the true meridian, variation is said to be east. Large masses of ferrous rock can disturb the Earth's magnetic field and give large changes in variation over short distances. Magnetic dip. The lines of the Earth's magnetic field emerge vertically from the north magnetic pole, bend over to run parallel to the Earth's surface, then descend vertically into the Earth's south magnetic pole. The angle at which the lines of force make with the Earth's surface is called dip. Dip is zero at the magnetic equator and maximum at the magnetic poles. Deviation. Aircraft compasses must be located in an area where the pilot can readily read them, i.e. the flight deck. They are therefore surrounded by all the electromagnetic forces induced by the flight deck electronic instruments. Deviation is the correction which needs to be applied to make compass readings most accurately reflect magnetic readings. Types of deviation. The aircraft magnetism which produces deviation is a combination of hard iron and soft iron magnetism. Hard iron magnetism is due to the influence of the Earth's magnetic field on the metal in the aircraft during assembly, due to hammering and riveting. Soft iron magnetism occurs when metal in the aircraft is magnetized by the Earth's magnetic field and/or by aircraft radio-electrical circuits which produce electromagnetic fields. The direct reading compass. The direct reading compass is used as a standby instrument in large aircraft. In terms of requirements, it must be horizontal, and this is achieved by pendulously suspending the magnet. Due to dip, this results in the CG, centre of gravity, being displaced closer to the equator. It must be sensitive, more than one magnet is therefore used, and a dual pivot system is suspended in fluid. It must be aperiodic, i.e. there are no oscillations, and it's liquid damped. Compass errors. Errors are caused by acceleration, deceleration and turning. Accelerations. In the Northern Hemisphere, we use the acronym ANS. Accelerate north, decelerate south. An acceleration will show an apparent turn to the north and a deceleration an apparent turn to the south. This is caused by residual dip of the pendulously mounted compass, which displaces the CG, centre of gravity, from its pivot point. Turning errors. In the Northern Hemisphere, UNOS. Turning through north, the compass will underread. Turning through south, the compass will overread. The remote reading compass. Advantages. The compass detector is placed in a magnetically neutral area of the aircraft. Heading information can be transmitted to other flight instruments. Gyro mode can be used when needed at high latitudes. Acceleration and turning errors are greatly reduced. With variation control, true and even grid headings can be steered. Remote reading compass components. It comprises a detector unit, a Selsyn unit and a directional gyro. The detector unit. This detects earth flux. Fixed in azimuth and pendulously suspended so as to be horizontal, with 3 flux valves set 120 degrees apart. An exciter coil is connected to each flux valve and supplied with 400 Hz alternating current. 3 stationary coils wrapped around the flux valves, and current induced in these coils by the Earth's magnetic field is fed to the stator coils of the Selsyn unit. The Selsyn unit. This is the self-synchronizing unit. It's situated in the vertical plane behind the compass card. It consists of 3 coils set at 120 degrees apart, the stator, and a rotor. Current in the stator coils induces a magnetic field around the rotor. If the rotor is out of alignment with the field, a current is induced in it, which causes the gyro via a precession amplifier to move. The gyro precesses in azimuth and turns a rotor until it lies at 90 degrees to the magnetic field in the stator. There is now no current, which means the gyro stops precessing. The compass card now indicates magnetic heading. Here's the instrument dial which controls it in the cockpit. It's got free and slave mode with a switch, and free means it basically becomes like a simple directional gyro which you line up with your direct reading compass. And you'd adjust it using the knob on the right, or switch on the right, which can turn it clockwise or counterclockwise, anti-clockwise. And a series of pluses or minuses or dots will appear on the left hand side to show you that it's precessing or moving. If you switch the knob over to free, it will automatically align up with magnetic heading. The gyro unit. The gyro precesses in azimuth and turns a rotor until it lies at 90 degrees to the magnetic field in the stator. There's now no current, which means the gyro stops precessing. The compass card now indicates magnetic heading.